When most people hear the word endometriosis, they think of a reproductive condition defined by painful periods, infertility, and pelvic disease. For decades, it has been framed almost entirely as a gynecological disorder confined to the uterus and surrounding reproductive organs. But that explanation is no longer sufficient. Modern research increasingly suggests that endometriosis is not simply a condition of misplaced tissue. It behaves like a systemic immune disorder, one rooted in immune dysfunction, chronic inflammation, and altered cellular signaling throughout the body. In this model, the immune system is not just reacting to the disease. It is actively participating in its persistence. To understand this shift, we need to move beyond the uterus and into the immune system itself. Endometriosis occurs when endometrial-like tissue grows outside the uterus. These lesions can appear on the ovaries, fallopian tubes, bladder, intestines, and in rare cases, even the diaphragm or lungs. These tissues respond to hormonal cycles, thickening and breaking down in response to estrogen and progesterone, just like uterine lining. One widely accepted explanation is retrograde menstruation, where menstrual blood flows backward through the fallopian tubes into the pelvic cavity. This process happens in a large percentage of people who menstruate. Yet only a fraction develop endometriosis. This discrepancy is the first major clue that something beyond anatomy is involved. If tissue is entering the pelvic cavity in many individuals, why does only a subset fail to clear it effectively? The answer appears to lie in immune surveillance. Under normal conditions, the immune system rapidly clears misplaced endometrial cells from the pelvic cavity. Macrophages engulf cellular debris, natural killer cells destroy abnormal cells, and T cells coordinate immune responses to maintain tissue balance. In individuals with endometriosis, however, this system behaves differently. Macrophages are present but dysfunctional. Instead of efficiently clearing debris, they become overactivated and release inflammatory cytokines. Natural killer cells show reduced cytotoxic activity, meaning they are less capable of destroying misplaced endometrial cells. T-cell signaling becomes altered, contributing to chronic inflammation rather than resolution. The immune system is not absent. It is present but misdirected. This is a critical distinction. Endometriosis is not a condition of immune failure in the sense of inactivity. It is a condition of immune dysregulation. When endometrial-like cells are not cleared, they attach to pelvic surfaces and begin to survive in a foreign environment. These cells do not behave passively. They actively adapt. They recruit blood vessels through angiogenesis, allowing them to establish a nutrient supply. They invade surrounding tissues and begin forming lesions that can grow, bleed, and trigger inflammation during hormonal cycles. Unlike cancer, these cells do not metastasize uncontrollably. Instead, they depend heavily on hormonal signaling, especially estrogen, for survival. This creates a biological loop involving three systems: hormones, immunity, and inflammation. Once established, this loop becomes self-sustaining. One of the central features of endometriosis is chronic inflammation within the pelvic environment. The peritoneal fluid in affected individuals often contains elevated levels of inflammatory cytokines, such as interleukin-1, interleukin-6, and tumor necrosis factor alpha. These molecules reshape immune behavior. Macrophages become more inflammatory but less effective. Natural killer cells become further suppressed. fibroblasts are activated, contributing to scar tissue formation and adhesions. At the same time, inflammatory signaling enhances lesion survival. This creates a paradox. Inflammation, which is meant to protect the body, ends up sustaining the disease. Estrogen plays a central role in this immune dysfunction. It is not only a reproductive hormone, but also an immune regulator. In endometriosis lesions, local estrogen production is often elevated. This occurs in part because inflammatory immune cells express enzymes that increase estrogen synthesis within the lesion environment. This creates a feedback loop. Inflammation increases estrogen, and estrogen increases inflammation. Estrogen also suppresses certain immune responses, further reducing the ability of the immune system to clear lesions. The result is a localized microenvironment where immune defenses are weakened, inflammation is amplified, and lesion survival is enhanced. There is no single cause of immune dysfunction in endometriosis. Instead, multiple overlapping mechanisms appear to contribute. Genetic susceptibility plays a role. Variations in genes involved in immune signaling, inflammation regulation, and tissue repair may influence how the immune system responds to endometrial cells outside the uterus. Environmental exposures may also contribute. Endocrine-disrupting chemicals, chronic stress, and early immune system challenges may alter immune development and responsiveness. The pelvic environment itself becomes altered over time. Peritoneal fluid in endometriosis contains elevated inflammatory molecules that continuously reshape immune cell behavior, reinforcing dysfunction. One of the most consistent findings in endometriosis research involves natural killer cells. These cells are part of the innate immune system and are responsible for identifying and eliminating abnormal or misplaced cells. In healthy individuals, they effectively clear endometrial cells in the pelvic cavity. In individuals with endometriosis, natural killer cell activity is significantly reduced. This reduction is not just functional, but also signaling related. Receptor expression on immune cells is altered, meaning they receive distorted instructions about when to activate and when to suppress activity. This allows endometrial-like cells to evade immune detection and survive long enough to implant. Macrophages normally act as cleanup and repair cells. In endometriosis, they become central drivers of disease progression. Instead of resolving inflammation, they maintain it. They release growth factors that promote blood vessel formation and support lesion survival. They also secrete cytokines that recruit additional immune cells, perpetuating a cycle of inflammation. This represents a fundamental shift in immune function, from resolution to persistence. Although endometriosis is not classified as a classical autoimmune disease, it shares several features with autoimmune conditions. There is chronic inflammation, immune recognition of self-like tissue in abnormal locations, and in some cases, the presence of autoantibodies. However, unlike autoimmune diseases such as lupus or rheumatoid arthritis, there is no single defined autoantigen. For this reason, endometriosis is best understood as an immune dysregulation disorder with autoimmune features rather than a true autoimmune disease. This distinction matters because it reframes the condition as a problem of immune communication rather than simple immune attack. While endometriosis is often discussed as a pelvic condition, its effects extend far beyond the reproductive system. Many individuals experience fatigue, gastrointestinal symptoms, cognitive difficulties, and widespread pain. These symptoms are consistent with systemic inflammation rather than localized disease alone. Inflammatory cytokines circulate beyond the pelvis, affecting multiple organ systems and altering how the body processes pain and fatigue. Pain in endometriosis is not solely caused by physical lesions. It is also driven by immune signaling. Inflammatory cytokines sensitize nerve endings, lowering pain thresholds. Nerve fibers can grow into lesions, further amplifying pain signals. This creates a neuroimmune feedback loop in which inflammation increases pain sensitivity and pain signaling reinforces immune activation. This explains why symptom severity does not always correlate with lesion size. One of the most challenging aspects of endometriosis is recurrence after surgical removal of lesions. This suggests that removing visible tissue does not resolve the underlying immune dysfunction. The immune system appears to remain in a primed inflammatory state, capable of supporting lesion regrowth. As a result, endometriosis is often a chronic recurring condition rather than a one-time structural problem. Emerging research suggests that the gut microbiome may also play a role in immune regulation in endometriosis. Alterations in gut bacteria have been observed in individuals with the condition, potentially influencing systemic inflammation and immune signaling. Because the gut is a major regulator of immune activity, changes in microbial composition may contribute to immune dysregulation seen in endometriosis. Taken together, these findings support a major shift in how we understand endometriosis. Rather than viewing it as a purely hormonal or anatomical condition, it can be understood as a multi-system disorder involving immune dysfunction, chronic inflammation, hormonal feedback loops, and neural sensitization. The lesions themselves may be the visible outcome of deeper systemic processes. The immune system is designed to protect, repair, and restore balance. In endometriosis, these functions become altered in a way that allows persistent inflammation and tissue survival outside the uterus. The result is a disease that is not simply about misplaced cells, but about a misregulated immune environment that enables those cells to thrive. Understanding endometriosis as an immune disorder does not replace older theories, it integrates them. Hormones, inflammation, genetics, and environment all interact within a broader immune framework. And within that framework lies the future of treatment, not just suppressing symptoms or removing lesions, but restoring immune balance in itself. In that sense, the story of endometriosis is ultimately a story about immune precision and what happens when that precision begins to break down.